Maybe you're trying to recover the seed or the passphrase for your wallet, but you don't have the address. One of the great things with BTCRecover is that you can use it with what is called an address database. That's basically where you take a list of every address ever used for the blockchain that you're trying to do the recovery for, and you run BTCRecover against that. And as long as you've got enough RAM to be able to fit the address database in there, there is no real performance penalty for doing this. In the past, I've done a video for how to create and use address databases for things like Bitcoin Core and Litecoin, where you basically just use the full node software to download the whole blockchain and create the address database from there. But one of the other options that I added last year was the ability to create an address database from just any list of addresses. You can then couple this with Google BigQuery to be able to create address databases for things like Ethereum, Dash, Dogecoin, and other networks where the previous process doesn't work. I just happen to be doing some recoveries right now where I need an updated Ethereum address database, so I thought I'd just run through the process on how to create an Ethereum address database for BTCRecover using Google BigQuery. And if you haven't already done so, hit subscribe. That way you can stay in the loop for content I make to help you find your way in the crazy and often hostile environment that is cryptocurrency. First thing you need for this is a Google account. Any free Gmail account will do, and we're going to head to cloud.google.com. And once we're there, we're going to click on console. You're going to have to accept the terms of service. You don't have to accept the email updates. We'll agree and continue. And if you've never used Google Cloud Platform before, you're going to be eligible for some credit, which will more than cover the costs of what we're going to do here. If you have used Google Cloud Platform before, it'll only cost you a couple of bucks at most. So I'm actually going to activate that free trial. And you're probably going to just say it's a personal project and continue. Now, before we go any further, I should spell out that if you want to use Google BigQuery and any of the Google Cloud Platform stuff, you will need to add some payment information, even if you use the free trial. And just as a reminder, you can download pre-built address databases in the BTCRecover documentation. Find those, you just go onto the BTCRecover documentation website, just click on Seed Recovery, the address database one there, and you can actually click on this link here, which will take you to a list of different address databases that are totally ready-made that you can just download. And look, I do update these from time to time, dependent mostly on how often I'm having to update them and use them for different recoveries that I'm running for folk. But anyway, back to how to do it yourself. So just got to answer these questions. You could say anything. I'll just say data analytics because I think that's what this is. Next. There we go. And we're not going to worry about any of these tutorials. So here we are. Okay, so basically we're going to need a few things on BigQuery. So the first thing we're going to need to do is to create a storage bucket. This is where the files that we have are going to go. So we'll just say create bucket. So you've got to pick a name for your bucket. It has to be globally unique. So we could just call it BTC recover, and I don't know, I'll just put today's date. That'll do. Can be anything, and we'll say continue. Now, in terms of where you store your data, this is not actually going to matter a lot because we're not storing a massive amount of data for a long time, but if you do forget to delete the data afterwards, it definitely could make a difference. But my suggestion here is that performance doesn't matter very much, so just go for the cheapest data you can find. And basically you'll see here over on the right, as we select different regions, there'll be different pricing. So just select single region and basically just pick and just try a few different regions and just find the cheapest thing that is reasonably close to you. So, I'll just go with US East, say continue. We'll just leave it as standard and we'll just use uniform access control because we don't need anything more than that. We don't need to worry about versioning or anything else, so we can just say create. All right, so we now have our storage bucket, and this is where the data from BigQuery is going to end up. Next thing we're going to do is open a command prompt. The assumption here is you actually already got Python installed and working on your system. If you haven't done that, go over to my video on installing BTCRecover and follow the instructions there for your environment, then come back and do this process. So in our command prompt, we're just going to type pip3 install GSUtil. Despite the fact that I got a bunch of warnings, it did successfully install everything we need. So once we've done that, we'll just say GSUtil config, and that's going to prompt us to log in to our Google account, meaning that this command line tool can download the things from our Google Cloud Platform account. So we'll copy that. We'll right click to copy it on our mouse. Then we go back into our browser. We'll just open a new tab, and we will just paste that address from the command line into there and hit enter. And it's going to take us to sign in. Essentially, we choose the Google account we want to use. And then we're just going to say yes, we want to allow it to configure our Google Cloud data. And then what happens is we copy this code here, and we then paste it back in command prompt. So if I just select this window now and right click, it will just paste it in there, and I can hit enter. And there we go. So now we just need to give it our project ID. So we'll just go back to the tab for the Google Cloud Platform. And in this instance, I've just been using the default, which is my first project. And we'll just use this project ID here. Copy, right click again to paste, and hit enter. And there we go. So we've got this set up to be able to download the data from the Google storage space bucket we created before. So what we're going to do now is we are going to go back to the BTCRecover documentation. It's just at btcrecover.readthedocs.io. And the place we want is we're going to go into seed recovery. We're going to go into recovery without addresses, and the BigQuery things we want are just down the bottom of the page. And I've actually got some queries that I have pre-written that you can actually just use. So for example, one for all Ethereum addresses. So you click on that link, it'll take you to Google Cloud Platform, and it will put this query in your editor. We don't actually want to hit run straight away. We are going to go on to more and basically go into query settings. So the first time you run this, you are going to have to create a new data set. So we will say create new data set. We'll just call it demo, and we will just say US. If you select some of these other regions, you might actually find that you get an error saying you don't have permission to access the queries we need from Google BigQuery. So we'll just leave that as US multiple regions, and we will say create data set. All right, so we'll just give it a table ID. So we'll just call this ETH addresses. In terms of these settings, we'll just say write if empty, so we'll assume you don't have a table there for that. We will say allow large results, just in case you're using something like Bitcoin. And in terms of these other settings, we want this to run, while we're here, so we will leave that as interactive. And we can just leave everything else alone. So we'll say save. And basically, once we have set those settings up, we can just click run. Now, even for Ethereum, this is going to take a little while to run, so if you're going to go and get a coffee, now is a good time to do that. That is finished, and now what we have are our results, which is essentially just a list of every Ethereum address ever used. And if we click on the expand node over here, we can actually see that data set that we created before, and we can expand it again. And here is a table with the results of the query we just ran. So if we click on preview, we'll see that same data. So what we are going to do here is we are going to export it to cloud storage. So we're just going to say export, and we want to say export to Google Cloud Storage. So we'll click on that. Now over here, this is where we are going to set the bucket that we created before. So we just select the bucket that we had. Now, in terms of file name, you can call it whatever you like. So we'll just call it ETH addresses. But this bit's important. So you need to finish that with an asterisk, because what's going to happen is it's going to basically give us a bunch of files that start with ETH address, and they're going to be incremented with a number here on the end. And this is how we tell it to do that. So then we'll just say select. We'll leave the format as CSV, leave compression as none, and hit save. And basically, we can see down here that the export was initiated. So we're going to go back to Google Cloud Platform. We're just going to leave because we don't need to save what we had. And we're going to go back to our storage browser. And if we click on that bucket, we can see there's a bunch of files there, but they're actually not all in order yet. The export is still going. So if I refresh that, you'll see that there's a bunch more files now. and the message saying that the export is happening has gone. So here are the files, and again, you'll notice that they all start with ETH addresses, and where the asterisk was has just incremented through all these different numbers. Now, you could download all of these files individually, but that's going to take a long time, so I'm not going to do that. But what we're going to do is we are going to copy the path to the clipboard here for our bucket, because we're going to need that in a sec. So we're going to go back to our command prompt, and we are going to create a folder where we want these files to go. I can either do that just in the command prompt or just using Windows Explorer, and then we're going to navigate to that folder. And once we're there, we are going to download all the files. So we're going to use GSUtil, and we're going to add some arguments. So firstly, we want it to do a multi-threaded download, so it's not just going to download one file at a time. We are going to copy, and we're going to download all of the files. And the address we're going to give it is this, so gs:// and then we're going to right-click and paste our bucket name. Then we're going to put in the local folder where we want it to go. So I'm just going to say C ETH addresses and hit enter. And now it's going to download all of those files. Again, depending on the speed of your internet connection, this might take a while. All right, it is a bit later and the download is done. And look, I'll just show you what we downloaded. So basically, if we go into the folder where we downloaded everything and just click in there, we have a bunch of these files. These are all the same ones that we saw in Google Cloud Storage. And if we open them up, they're just text files full of Ethereum addresses, you know, one address per line. And so what we're going to do now is we've downloaded them all to this folder. So if I type dir and hit enter, we can see that it has created a folder for that Google Cloud Storage bin called BTCRecover. So we'll go into that, cd space BTC. So what I'm going to do now is I'm actually just going to open another command prompt window. And we're just going to navigate to the BTCRecover folder. Again, make sure you navigate to your BTCRecover installation folder, not mine. So we're going to say Python. And the file we're going to use is create address database. And if we just start typing it and hit the tab key, it will actually autocomplete. Now, I'll just type in help and show you some of the commands that it has now. So we're going to say Python create address-DB.py, and what we're going to do here is we are going to say input list file. For the parameter for this argument, we're going to go back to our other one, and we're going to copy the folder. We're going to copy the folder that we had these files in, and we'll paste that there. And we're also going to put an extra trailing slash on there, and we're also going to copy the file name of the first one. So this is the one with all of the zeros. And we're going to right click that, and that will copy it. Now if we go back into here and right click to paste, we can see that we've basically put in the full path to the very first file. Now we'll put in a space, and we're also going to use this argument here. So we'll just type in --, multi-file input list, and there we go. The other thing here is I can also add a DB file name parameter, which will essentially tell it where to put the address database, DB file name, and we'll just call it ETH addresses, and we'll just put today's date. Now, the last parameter that I'm going to talk about is this DB length. This basically tells the address database how much space it needs to allow in there. If we go back to the documentation, I actually have the thing here, which is the parameters to manage the address DB size. And as it stands right now for Ethereum, the required DB length is 28. So we'll just copy that. Last I checked, it was about 120 million, and that should work. So we'll just copy that. So we'll go back here, and we'll say DB length 28. It will work without this command, but you will end up with a much larger address database than you need. The default basically is going to be big enough to accommodate the entire Bitcoin blockchain. Turns out 28 is no longer enough. I actually just went to run the create address database command. It got most of the way through, but then ran out of space and failed. So you will need to use 29 for the Ethereum blockchain as of April 2022. So we'll basically just run that with 29. And we're actually going to say force because the old file that was unsuccessful is actually still there. We could just delete it, or we can just say force and that'll just overwrite it. And we'll say enter. And we'll let that run again. Except this time it's actually going to run with enough space for 400 million addresses. It'll probably be good for the next year or so at least. So it's essentially now just going to load through all of the different files and skip any invalid addresses that it finds. We'll also get an update every 1 million addresses as it goes. Anyway, just like the download, this is going to take a while, so go away, grab a coffee, come back later. And there we go, so that is done. And if we have a look in the BTCRecover folder, we can see that our newly created address database is there. So that's all the ETH addresses up to today. To use that address database, it's simply a case of adding it in the command line. It'll work for either SeedRecover or BTCRecover. There we go. And if we test it out with just the Ethereum address that I used for a video last month, there we go. It finds the seed just fine, whereas when I ran that with the older address database back from before that seed had been used, it won't find anything because obviously the address isn't in the address database at that time. Now, the other thing that we can also do after we've created an address database, if we just want to double check everything, is we can use the Check-Address-DB.py. And I'll just copy this example command here and we'll just edit it from there. The address database we just created. And we'll just change the address database to be the one that we created before. So if we run that, it'll basically just load the address database and just check against a bunch of different addresses. And we can see that was one of the test wallets that I used in a previous video from March 21st that was found in this newly updated address database, whereas when I run that against the older ETH address database that only goes up to the 4th of November 2021, we can see that this most recent address here is not in there. Meaning that if we were trying to recover the newer wallet but didn't know what our wallet address was, using it with the older address database would not have worked. The addresses associated with your wallet need to have been used at least once before the address database was created. Otherwise, the seed will not be successfully found. This process doesn't just work for Ethereum, and I actually have Google BigQuery queries there for Bitcoin, Ethereum, Doge, Bitcoin Cash, and Litecoin, because this can be faster than just downloading the entire blockchain if you prefer. And if in the future Google add additional crypto datasets to BigQuery, in addition to the ones that are already there, you could pretty much just use this same process as well. Now, the last thing you need to do is make sure you take time to clean up, and that's remove the database result that we saved and to remove the files from Google Cloud Storage, because if you leave them on there, Google will bill you for them. So we just expand the default space created with our project, and we can either just delete the entire data set or we can just delete the table. Really, it doesn't make a difference which one we delete. And just because I might come back and do this in the future, I'll just delete the table. So we'll delete that. It prompts us to confirm the action, so we just type in delete. There we go. And that has been deleted. And now the other thing we need to do is go back into the cloud platform, go into the storage browser, and either delete the entire bucket that we used for this, or just delete all of the files. And there we go. So there you go. The ability to use address databases is a really powerful feature of BTCRecover because not everyone will have records of the addresses associated with wallets that they can no longer access. And the ability to create an address database just based on any list of addresses can be really helpful too, regardless of whether you're trying to run BTCRecover against an entire list of every address ever used, or if you instead just have, a very long list of possible addresses and you want to check all of them. If you've got any questions about this, or if you get stuck, just leave a reply in the comment section. I'll do my best to reply to everything there. And again, if you're totally stuck and want help with this, there's information about how you can reach out and organize a sort of private session on my website. Thanks for watching. I hope that was helpful. Hit like if you think that other people would find this video useful, and hit subscribe if you'd like to be kept in the loop about future content I make that helps people stay safe in the crypto space and to recover if they get into trouble. If you have any questions about this video or a topic that you'd like me to cover, just leave a reply.